And as a reminder, for more Microsoft Webcasts, you can visit microsoft.com/webcast. And again, I'd like to welcome everyone to today's Msdn Webcast, Authorization, Privilege, and Access Control in SQL Server 2005. And now, without any further delay, I'm going to turn the floor over to today's presenter, Adam Mechanic.
Hi, thank you for joining me for today's webcast. Today we're going to be talking all about how to secure your data in your SQL Server 2005 databases. Before we begin, I'd just like to take one moment and promote my new book coming out May 21st, Expert SQL Server 2005 Development. I'm going to be giving out a few free copies at the end of this webcast, so please stay on. And if you're interested in the kind of material in the book, you should note that this webcast is actually based on Chapter 4 of the book. So let's get started. What we're going to cover today, as I mentioned, is how to secure your data. So what you see here is a kind of simplified illustration of, from a development point of view, the layers that are involved in data security. And so we start at the outside world. We have authentication. That's everything before someone actually hits your server and actually getting authorized onto your server. Once we get there, we get into the SQL Server permissions layer, stored procedures, and then maybe onto some encryption. And then finally, if a user has passed all of those hurdles, they'll finally get to the data. So today, what we're really going to talk about is right in the stored procedure layer and the SQL Server permissions area, and actually setting permissions on data and authorizing access to data in other ways. So our agenda is as follows. First, I'm going to introduce some terminology. The terminology has changed a little bit with SQL Server 2005, so just important that we're all on the same page. And I'm going to show you some of the kind of new administrative statements that have been added to SQL Server 2005 for managing logins and users. Then I'm going to talk about proxies, which are principals, logins, and users without any passwords. So principals that cannot actually interactively log in. From there, we're going to move on and discuss schemas, which are basically logical authorization containers that you can create in SQL Server 2005. And then we'll talk about how to actually dynamically authorize users to view different data that they may or may not have access to already via ownership chaining, impersonation, and escalation of privilege through certificates. And finally, I'll show you a little bit about how to administrate this stuff. So to begin with, the general terms that you need to know when you're working in SQL Server 2005, and you'll see these in books online, are securables and principals. And it's pretty straightforward. A securable is anything that you can grant permission to. So for instance, the server itself, a database object, any of those things are securables. The users or logins to whom you grant those permissions are your principals. And if you look at security throughout SQL Server, everything's pretty much the same. You always grant a certain permission on a securable to a given principal. And so once you get the pattern, it's very straightforward to handle permissions. So in SQL Server 2007 and previous versions, managing logins and users was a little bit annoying. You had to use a lot of different system stored procedures like SP add user, SP add login, and there was a different stored procedure for Windows logins and SQL Server logins, and it got a little annoying. So what the SQL Server team has done in 2005 is created DDL to replace these stored procedures. So this is really a lot nicer experience from a scripting and administrative point of view. If you have to type things out, you don't have to remember the correct stored procedure. You just create login, drop login, just like creating a table, database, anything else. So really very nice. And as I'll show you next, along with these enhancements comes the ability to create proxy principals, which are principals that can't actually log in. And I'll show you how that works in just a moment. So that's next on our agenda. I'm going to talk about those proxies and the GDR which is grant, deny, revoke. So first of all, we can create proxy users. Those are database users without a login, or database users created based on cryptographic certificates. And I'll show you a little later in the webcast why you might want to do this. But the basic approach that you should think about as you listen to me today is that you want your application or your users logging in remotely to have as little access as possible. You want them to have least privilege. And you want them to log into your server and then selectively escalate their privileges up in order to get more access to whatever resource they need. So, for instance, a user logging in remotely may or may not have access to a table, but they can call a stored procedure, which will enable them to briefly escalate up their privilege, get the data from the table, and then return back. And by controlling things in this manner, you can very granularly make sure that users can only get the data that they need exactly when they need it, and not at any other point. So that's the basic idea behind these proxies, and I'll show you how they work in detail. Next is proxy logins. We can't create a login without a password like we can with a user, but we can create a login based on a cryptographic certificate, just like a user. So again, these can be used, and I'll show you how to extend privileges dynamically to interactive logins. And finally, this is probably old hat for those of you who've done a lot with SQL Server in the past, but the key to all authorization in SQL Server is GDR, grant, deny, or revoke. So we can grant permissions at both the server level and the database level. At the server level, for instance, we can grant the alter any database permission to a login. That means that the login can go and run alter database for any database. Another really cool one that was added to SQL Server 2005, brand new permission, is grant alter trace. And what this one does is allow that login to use SQL Server Profiler. And that was, of course, a nightmare in SQL Server 2000, where developers maybe wanted to use SQL Server Profiler to help debug some problem that the application was having, but you needed administrative permission on the instance to run SQL Server Profiler. So you don't need that anymore. All you have to do is give your developers this grant alter trace access. At the database level, we can grant access to tables, to store procedures, and all kinds of other things using the same thing, grant, revoke, or deny. And of course, the point of deny is that the user might be a member of a role which has access to something, but you don't want that specific user to have access. So you can very granularly control things. So let's go over to some slides, to the SQL Server Management Studio and check out how some of this works. So what I'm going to do now is create a certificate in the master database. And this is a cryptographic certificate. And I'm encrypting it with a password, and I'm calling it login certificate. And now I'm going to go ahead and create a login called proxy login based on the certificate. Now this login cannot actually log in interactively to the server. It's just a virtual construct used to grant permissions. So now I can go ahead and actually give it alter any database permission. Now I'll show you later in the webcast how you can actually use that grant from an interactive login, so you can protect your permissions that way. One thing to watch out for, by the way, when you're creating these certificates, one of the unrequired options is an expiration date, and by default, the certificates expire 1 year from the date that they're created. So that means if I were to have created this login today and created some code that relies on this login, a year from now, it's going to break. So there is an expiration date option you can set when you create your certificate. If you are creating a proxy, you probably want to set that to sometime in the distant future. Most likely you don't want that to actually expire on you. So I'm going to go into the TempDB database, and I'm going to create a proxy user. That's a user without a login. I've just created that. And now I'm going to create a table, and I can grant access on the table to the proxy user. So just like any other interactive user, I can go ahead and do my grants, denies, revokes, and again, we can use that later. I'll show you how to selectively increase the permissions that an interactive user has. So I'm going to go ahead and clean up now, and we'll jump back into the slides. So next, we're going to talk about schemas. And schemas are a new idea in SQL Server. They're from the ANSI standard, and they're logical containers into which you can put objects and into which you can authorize users en masse. So if you look in the AdventureWorks database that ships with SQL Server 2005, for instance, you can see that there's a sales schema, and it contains tables that relate to sales data. There's a purchasing schema that relates to purchasing data. And that's great from a logical organization point of view. But an even better thing is from an authorization point of view. You can grant a user access to the schema. For instance, you can grant select on the schema to a user, and that user will automatically have access to everything within the schema. And as you add new things to the schema, as you take things out of the schema, that user's access will keep itself updated. This is totally different from roles, which were kind of the closest way of controlling things in a logical way that we had previously. In a role, if you apply a user to the role and then you create a new table, you'd have to grant the role access to the new table. And so you'd have to do some ongoing maintenance there. Schemas get you out of that game. And one thing to note here is that when you are working with a schema and you're working with a grant or deny or revoke, you have to dereference it using the schema : notation that you see on this slide. So the way we work with schemas is, first of all, you should note that everything in SQL Server 2005 belongs to a schema. This is totally different than SQL Server 2000, where everything was owned by an owner. And I'll get into ownership in just a minute, but in 2005, everything's in a schema rather than necessarily owned by an owner. So every user has a default schema, and for most users, that's DBO. So, and by default, that's DBO. So when you create a new user, they automatically are in DBO, and everything works very similarly to the way it did in SQL Server 2000. But, of course, we can go ahead and change that. So we can set up sales users or production users or purchasing users, and we can set their schemas to the default schema for that kind of data. And then they will be able to get to the tables in there without referencing them by schema. So let me jump into SQL Server Management Studio again and take a look at how that works. So I'm going to go ahead and use the master database. I'm going to create a login called new login. And I'm going to jump into TempDB. And I'm going to create a user from that new login. And just a note on that create user DDL, if the username is the same as the login name, I actually don't have to reference the login name in create user. So just a nice little feature if you're creating a lot of users based on a lot of logins. You don't have to worry about typing some more characters. So now that I'm there, I can go ahead and create a schema. Call it my schema. And I am going to let new login select data from any table in my schema. So I've just done that. And now I can go ahead and I can create a table. I'm going to call it my table, has a single column, and I'm going to insert a row into it. Now I'm going to go over here to this other window. I'm going to reconnect using new login. I'm going to use TempDB. And remember, I've given new login access to the schema. So now new login can go ahead and select the data from my schema.mytable. And we get the row back. Now, if I want, I can change new login's default schema in the database. So I've just made the default schema for new login my schema. What that means is that all queries that don't reference a schema will first look in the default schema, then go look in the DBO schema. So now when I go back over to the other window, instead of using that two-part name, I can reference the table based on a one-part name. So that's really handy for users that need to access data in a certain schema over and over and over, save them quite a bit of typing over the lifetime of the application if they don't have to keep qualifying everything by schema name. Now, if I created a second table in the schema, I'll call this one My Other Table, and I'll also insert a row into there. This is the wonderful thing about schemas. The permissions automatically propagate. So because the user has select on the schema, they automatically get select on the new table. So this means releases you from having to do a lot of ongoing maintenance of permissions as you add and delete objects from the database. So another thing we can do is actually transfer objects. To do that, I want to move My Other Table into DBO. So again, I alter schema DBO, and I transfer in my schema dot My Other Table. And now, My Other Table is prefixed with DBO. Now when I go back to the other window, I actually don't have access to My Other Table anymore because it's now in that DBO schema. So this again allows me to control very granularly the kind of access that my users have. So I'm just going to go ahead and clean up here. And I'll jump back into the slides. So it looks like we have a question here. Is a column an object? And the answer is yes. You can grant access to a column just as you'd grant access to anything else. When you grant access to a table, access to that column is automatically granted. So you don't generally have to worry about that, but sometimes you'll want to do something like deny access to a certain column to a certain user or subset of users. For instance, if you have a column that has sensitive data like address information, you might want to look at encryption for that, but if you don't need encryption, if you just need to keep certain people out, you can just deny access to that column. So that's a nice way to control things sometimes. So let's move on. Just a little more on why you want to use schemas. Oftentimes in databases or in applications I've worked with, I've seen situations where people, to logically organize things, will create multiple databases. So rather than the example we just saw where there was one schema for sales and one for purchasing, there would actually be one database for sales, one database for purchasing, one database for marketing. All of these different databases, well, the fact is quite often there's interrelations between these databases, and they're very difficult to enforce because you can't create cross-database keys. So oftentimes people will have to include something together with triggers, something like that. That's really not necessary anymore with schemas. Because schemas all live in the same database, you can create foreign keys between those objects. So that's a really good way of making sure that your data integrity is intact and you have better data and better databases. So I would definitely move towards schemas and kind of move away from that multiple database model as much as possible. Consolidation is a good thing. Another note is that any object within a schema can be owned by someone other than the schema owner, but we'll get into that in one moment. Probably not something you want to do very often, but just something you should know. And it looks like we have one other question. Are users, logins, and roles restricted to one schema only? So the answer here is no. A user can have only one default schema, but a user can certainly have access to as many schemas as you want to give them access to. Same with roles. Logins don't actually have any kind of access directly on schemas because they're server principals, not database principals. But the users associated with those logins certainly can. So I hope that answers your question. And one other question here, just for clarification, if the username is the same as the login name, what you don't have to do is when you use that create user syntax, there's actually an option, create user for login. And you don't have to use that option for login if the username is the same as the login name. SQL Server will automatically go look at the logins and say, oh, we already have a login for this user. That's okay. Let's move on. Talk about ownership and chaining. So now we're going to finally get into the authorization part of this talk. And the basic and most common way that we authorize users is through ownership chaining. And so first let's just talk about ownership a little bit. In Microsoft SQL Server 2000, whenever you created an object, the default for that object was that it would be owned by the user that created it. So if user Fred were to log into the server, create a table, all the other users would access that table by Fred.tablename. And they would do that because user Fred created it. In SQL Server 2005, things are a little different. Most objects actually don't have explicit owners. They inherit their owners from whoever owns the schema in which they're created. And every object in a database is created within a schema. So if we do want to change that ownership, we actually have to use alter authorization. So in this example, we're making my user the owner on my table. And one thing to keep in mind is that when you do change that authorization, all of the grants and denies and revokes on the object are reset. They disappear. So you have to definitely keep that in mind as you're working on this. We have another question. What is the schema for SA? So SA by default is associated with a database principal called DBO. DBO at this point is still a user, and I'll show you that when I get into the next demo. And so DBO is both a user and a schema. So it can get a little confusing in 2005. I think that moving forward, we'll probably see a bigger and bigger separation between those users and schemas. But for now, they're somewhat aligned just for the purpose of backward compatibility with SQL Server 2000. So the reason that ownership is important is because of ownership chaining. So what ownership chaining is you have a module in your database, such as a stored procedure or a view, and someone has access to call into this module. A user has access to it. And when that user calls into it, that user will be given access to any resources that are owned by the same owner that owns the module. So this is better illustrated, I think. So let's say we have a table, we'll call it table A, owned by user A, and we have a stored procedure that does select from the table. Now we also have that same stored procedure, proc A, is also owned by the same user, user A. Because they're owned by the same user, there's an ownership chain there. And when user B, which has no access to table A, calls into the stored procedure, user B, by virtue of that ownership chain, via the stored procedure, can select from table A. But user B cannot directly access the table. And this is really getting into the least privilege methodology that I mentioned earlier. This is where you want to give your interactive users the least possible access to resources and let them call in to escalate their privileges briefly, just enough to get whatever they need, but without actually letting them get direct access to things. This protects your data and basically keeps you safer, keeps your users from being able to do things they're not supposed to do. So you want to stay in control when it comes to your data if you have sensitive data in your databases. And ownership chaining is used probably 95% of the time to accomplish this. So let me get into SSMS, show you little example of how this works. So I'm going to go back to TempDB, and I'm going to create a table called X, and I'm going to insert a row. And now I can look at the ownership for the table. I'm going to use the sys.objects view. This is a catalog view new to SQL Server 2005. And what we can see is that for our object name X, which is our table, the principal ID is null. That means there is no explicit owner for the table. That doesn't mean that it doesn't have an owner, however, because every object inherits its owner from the schema if that hasn't been overridden, and its schema is DBO. So to find out who actually owns an object, what we need to do is join to the sys.schemas view, and we join on the schema ID column. And then, if the object's principal ID is null, we use the schema principal ID. We know that that's the actual owner. So now we find out that our actual owner is principal ID 1. Now if we want to find out who that is, we can use the username function. So we select the name, principal ID, and username from the sys.schemas table. So let's go ahead and do that. And we find out that principal ID 1 is DBO. So DBO currently owns table X. So now I'm going to go ahead and I'm going to create a new user, a proxy user, without a login. And I'm going to make that user the owner of X. So now when I go back and run this query, I see that I've overridden the access and principal ID 5, which is not listed now as access. And they're not listed, by the way, because they're not a schema. So I would have to use username 5 to get that. So now we see, based on this modified version of the query, that does use the username function, which I should have used before, that new user actually owns the table now. So now I'm going to go ahead and create an interactive login called new login, and then I'm going to create a database user in TempDB for the new login. And I'm going to create a stored procedure called getX. And all this stored procedure does is select the rows from the table X. And I'm going to allow new login to execute that stored procedure. So now I'm going to jump over to another window here, and I'm going to log in as new login. I go to TempDB, and I don't have any privilege to query X. So that's a good thing. I don't want my interactive logins to have any privileges to query tables. So I do have access to execute this stored procedure getX, but that doesn't work either. My permissions were actually rechecked when I tried to run the stored procedure. And the reason for that is that there is no ownership chain right now. The procedure is owned by DBO because I didn't change its permissions, and the default schema for my login is DBO. The table is owned by new user, as you saw me change that. So when I look at this, this is all of the objects where the object ID is getX or X, so the stored procedure of the table, and the owners. As you can see, they're owned by different principals in the database. So what I want to do now is actually make new user the owner of the getX stored procedure. So I just did that. And now when I flip back here, it still doesn't work. Reason for that, as I mentioned before, you need to keep in mind that when you run this alter authorization on an object, all permissions are reset. So what I need to do is go back up here and again grant the permission to the new login for the getX stored procedure. Now finally, after all that, when I flip back over here, I get the data. So this probably seems a little bit complex, but it's pretty simple once you get it set up and running. And the real point is that we have not given the interactive login access to anything. We've only given access to proxy login, which no one can actually even log in as. So we've completely encapsulated our permissions in the stored procedure. So that's great, but as I said, it only works about 90% of the time. Here's where it breaks down. I'm going to change the procedure, and instead of selecting from the table directly, I'm going to use dynamic SQL. Now I realize this isn't a place you'd probably use dynamic SQL generally, but it's a simple example. So I'm going to go ahead and do that. I'm going to jump back over here to this other window and run getx again, and boom, I get an exception. Reason is that in dynamic SQL, a new context is used to execute the SQL that's run, and security is rechecked at that time. So you can't use an ownership chain. It's broken when you use dynamic SQL. So we'll get into some methods next on how to fix that. So I'm going to go ahead and clean up. Oh, I have to log out first. And we'll go back in here. Let me see if there's any questions pending. So someone asks, if I create a new instance of SQL Server 2005 rather than upgrade from 2000, is it during the installation that I could specify the schema for SA and do something different from DBO? The answer is no. You would actually be able to map that once the product's already been installed. During installation, you aren't given any option for that. Someone else asks, is there a caveat where the administrator himself can get into trouble if ownership chaining is used incorrectly? That's a pretty good question. I don't think there are many places where you can get into trouble with ownership chaining if you kind of keep your mind on what you're trying to do, which is keep the interactive user, not necessarily the administrator at this point. I think it's always assumed that the administrator is going to have access to data in the database and needs access to the data in the database. As an administrator, you're going to be asked by users, can you please go in and fix my data, or look and tell me what's wrong with my data. I think it's dangerous trying to control administrators in most cases and keep them locked in to this kind of ownership chaining exercise. Where you will want to do this is for your applications. So if you have an application login that's logging in and calling stored procedures or sending ad hoc batches, hopefully you will use ownership chaining based on views for those ad hoc batches rather than give it table direct access and control access via stored procedures otherwise. And if someone manages to penetrate your application server and get direct access to your database that way, if you've encapsulated everything in stored procedures or views, the attacker won't be able to do much. And that's really the point, is to protect our data from people who aren't supposed to see it, not necessarily the people who are. So another question is how to keep a record of authorization before I make the switch. And if you can rephrase your question, I will address it. I'm not sure I understand it. And the next question, in dynamic SQL, ownership is checked, and you can't use ownership chaining. That's correct. And I will show what is needed to correct that in just a next section. So I'll talk about that in a moment. And finally, what's the best practice for assigning the default schema for a Windows domain group? So this would be basically the same as assigning a default schema to any other principal. You're going to have a database user associated with the login, and your group is probably going to be aligned with some business purpose. So often in a Windows domain we see, just as we mentioned before, a sales group, a marketing group, other related groups that are aligned closely with some business or some piece of the business. And what we'll want to do is, if it makes sense, create schemas for those groups and assign their associated database users to those schemas so that those users can see data that makes sense for them to see. So you want to keep it fairly simple, I think, and try to align your schemas with the logins and the users in as simplistic a way as possible to meet all your business requirements. Obviously, business requirements aren't always simple, so that might be a pie-in-the-sky dream, but it's something to look forward to. So I'll take one more and then we'll move on. Can you force SQL Server 2005 to require two-part names all the time? And I'm not aware of a way to do that. So I'll say maybe, but I have not seen that personally. So moving along, let's talk about impersonation. And this is how we fix some of those broken ownership chains. Ownership chaining, in my experience, is the most common way that you're going to dynamically authorize users and let them see data for which they don't directly have access. But obviously we sometimes need more. So the next step up from ownership chaining is impersonation. So let's look at how this is done. First of all, we have this idea in SQL Server 2005 of an execution context. And we had this in SQL Server 2000 as well. There was a command called setUser, but wasn't nearly as flexible as what we have in 2005. So in 2005, what we can do is execute as user equals username. And what that will do, if the logged in user has permission to impersonate the other user, and I'll show you how that's done, we'll actually change that logged in user's context so that everything behaves as if you logged in as that other user. The important thing to note here is that everything is changed. If you have access to something and you impersonate another user that doesn't have access, your permissions will effectively be lost. You'll only have the permissions granted to the other user. If you want to revert back to your original login, you use the new revert command, and the suser, sname, and username functions you'll find will be extremely useful when you're playing around with execution context. These will tell you who you're actually impersonating. So if you've ever worked with Unix and done some impersonation there, you might be familiar with who am I. These functions are the SQL Server equivalent of who am I. So let's look at this in a little illustration. Let's say that we have a table called Table A, and it's owned by user A. And we have another user called user B with no access to the table. If user B has impersonation access for user A, user B can impersonate user A and then select from the table. And this in and of itself is probably not too useful. Again, our goal is to protect our interactive users and not give them too much access. And by giving them impersonation access, we kind of break that ideal. So instead of doing it that way, what we can do is actually use execute as in a stored procedure as part of the stored procedure's definition. So what that means is that if we create a stored procedure using this execute as, when the interactive user calls the stored procedure, for the duration of the stored procedure, SQL Server will treat them as if they've logged in as the other user. And this means that the dynamic SQL example that we saw before will actually work. The reason is SQL Server treats it as if the caller was actually logged in as the user. So when the security is rechecked when the dynamic SQL context changes, the check will come back positive. The user will have access. So let me jump over to SSMS again, show you how this works. I'm going to go to TempDB, and again I'm going to create a login. This time we'll call it user A. I'm going to go ahead and create a table called Table A, and I'm going to insert a row. And now I'm going to make user A the owner of Table A. I'm going to create a second user. There's a proxy user called user B. Can't log in as that user. And I'm going to create a table, table B, insert a row, and I'm going to make user B the owner of table B. Now what I'm going to do is I'm going to allow user A to impersonate user B. And of course, as I said, this is interactive. I'm just showing this for the sake of this example. I don't think you'd want to do this too often in a real application. So now user A can actually execute under the context of user B. So I'm going to go over to this other window. I'm going to log in as user A. I'm going to go to TempDB. Now, if you recall, I created two tables, table A and table B. User A has access to select from table B because user A is the owner of that table. User A has no access on table B. And so this works exactly as we'd expect. Now I've given user A impersonate access for user B. So user A can now say, I want to execute as user B. So I'm going to go ahead and run that. And now it's as if we are user B. We can select from table B, but we can no longer get any data from table A. We actually are user B as far as SQL Server is concerned. And if I want to go back, I could revert. But first, let's check out the suser, snames, and username functions. So right now we're impersonating user B. So user B, remember, is a proxy user. So rather than seeing a login name, which we usually see in this first column, we see this long kind of identifier, and this is something that SQL Server generates internally automatically for proxy users. Then over in this column, for the username, we actually see user B. So we are user B at the moment. I'm going to go ahead and run the revert. And when I ask the same question, we're logged in as user A. Our local database user is user A. So, as I said before, you're probably not going to use impersonation in a real app, interactive impersonation too often. So I'm going to go back over here and I'm going to remove that impersonation ability from user A. Now let's go ahead and encapsulate this in a store procedure. So I'm going to create a store procedure called getTableB, and we're going to execute that store procedure as if we were user B. We're going to select from the table. And of course, user B is the owner of the table. Now I'm going to let user A run that store procedure. So back over here, we're logged in as user A, and I can run the store procedure, and I can select rows from table B. So that's great. Same thing that ownership chaining gives us. So what happens if we want to do dynamic SQL? Well, again, we're going to execute as user B. It's as if we're logged in as user B. So the dynamic SQL happens to work perfectly. So that's very, very nice enhancement. You need to control access to dynamic SQL. So I'm going to go ahead and clean up now. I can log out first. And we will jump back over. It looks like there's a few questions. So first of all, if the window user A is in Windows group B, both A and B are valid SQL logins but have a different schema in the database. When A logs in, which schema would be used? So if a user logs in to the server and connects to a database, that user's default schema will be used for any queries where the user only uses single part naming. First it'll look in the default schema, then it'll fall through to DBO if it doesn't find the object in the default schema. Now, the important thing to note is that a user can have access to as many schemas as you want to give them access to. So you're really not limited to one schema for a user. You're just limited to one default schema. So it's really just a matter of that two-part naming. That's really the only difference there. The next question, will profiler show as the impersonated user? and I believe it depends on the event, but I think in most cases it should. Next question. Which schema becomes active when a user is impersonated? The schema of the original user or the impersonated one? So again, when you're impersonating a user, everything behaves as if you're logged in as that user. So you have all the same permissions, default schema, everything. So it's just as if you've actually logged in as that user. Now the beauty of this whole setup is that thanks to those proxy users, you can't log in as them. Therefore, you can only get access to the data by impersonating them, and you can completely encapsulate that access from your application logins and other user logins that shouldn't have direct access to that data. And we have one more question, and then I'll get back to the slides. What if I create a new instance of SQL Server 2005 and do not upgrade? I believe I already covered this one earlier. So during installation, you cannot specify a default schema for DBO. So let's go back to the slides and talk about an even more advanced scenario, and I'll show you where this can come in handy. This is signing via cryptographic certificates. So I already showed you how you can create proxy users or proxy logins via certificates, but I didn't tell you why you might want to do that. The reason is that you can actually grant access to resources, or on resources, to those users that you've created via the certificates. And then rather than use execute as or ownership chaining, you can actually sign modules, so stored procedures or views, using the certificates. And that will give you a slightly different way of controlling authorization. Unlike with execute as, when you assign a module with a certificate, it's actually additive. So the person that's calling the module, calling the stored procedure, will retain all of their own permissions, and then they'll inherit the additional permissions granted by the certificate. So this can open up all sorts of doorways to lots of different functionality. Let me jump back into SSMS and we'll take a look. So I'm going to go back to TempDB. I'm going to once again create a user and login called user A. And now I'm going to create two proxy users, user B and user C. And I'm going to create a table owned by user B. It's called table B. Let me get back up here. And I'm going to go ahead and insert a row into it and make table B the owner. I'm going to do the same exact thing for user C. So now we have three users. User A is interactive. Users B and C are proxy users. Users B and C each own a table. User A has no access. So here's our mission. We have a stored procedure, get table B and table C. And what we want to do is pull back data from both table B and table C, each of which are owned by different principals. So let's see what we can do here. First we might try an ownership chain. So we'll make user B the owner of the stored procedure. Well, I'm going to go over to this other window, log in as user A. I'm going to run the stored procedure, and user A doesn't have access to the stored procedure. So we'll do that first. Now I can go over here. So now my ownership chain partially worked. The select permission was denied on the object table C. Well, I did have permission, as it turns out, thanks to the ownership chain, to table B, but what I also need is access to table C. So that didn't really solve my problem. So what I can do, as it turns out, is combine these techniques. I am going to now alter the stored procedure. I'm going to use an execute as for user C, which has access to table C, but I'm going to leave user B as the owner. So now we are going to execute under the context of user C, but we're going to have an ownership chain by virtue of user B. So now when I run the stored procedure, we get back rows from both tables. So that's pretty nice. But sometimes things can get even more complex in our world, unfortunately. So let's create another user, user D. And we'll go ahead and create a table for user D and make user D the owner of the table. And now we have this monster store procedure, get table B and table C and table D. Now we want to pull back all of table B, all of table C, and all of table D, all of which are owned by different principals. And again, we don't want to share too much access to this. So we don't want to give user B access to table C or D. We don't want to give user A access to any of these tables. We want to encapsulate it all in the store procedure. So I'm going to execute the store procedure under the context of user C. That will give us access again to table C. And then once again, I'm going to make user B the owner. That will give us access to table B. I'll give user A access to execute the store procedure. And I'll jump over here, and if you're paying attention, you might guess what's going to happen next. Well, thanks to our ownership chain, we have access to table B. And thanks to our execution context, we have access to table C. But guess what? We can only have one owner of an object. So we can't create another ownership chain for table D. And we can only execute under the context of one user at a time. So we can't get table D that way either, because we're already doing that for table C. So this is where certificates come in handy. So what I'm going to do is first put the table back to DBO as the owner. And the reason I'm going to do that is so that I can drop the proxy user. Remember, I created that user without login. I've just gone ahead and dropped the user. I'm going to create a master key for the database, and this will be used to protect the certificate I'm about to create. And then I'm going to go ahead and create a certificate. Master keys and certificates and everything, by the way, are totally out of scope, really big topic. I recommend that you view a TechNet webcast by Lara Rebelke, which covers all this stuff in detail. So I'm going to create a certificate, and I'm going to call it certificate for user D. And then I'm going to recreate the user, but this time instead of using without login, I'm going to use from certificate, and I'm going to reference that user D certificate. So I've recreated the user. And once again, I'm going to make that user the owner of the table, again giving it access to the table. And finally, after all this, I'm going to add the permissions of the user to the store procedure by signing the store procedure with the certificate user dcert. What this will do, when I call the store procedure, it's going to actually add whatever permissions the user has to the permissions granted by the store procedure, by the ownership chain, by the execution context, whatever. So when I go back and run the store procedure a final time, I actually get back rows from all the tables. Everything's completely additive. And so this lets us do much more flexible things than with just ownership chaining or just execute as. So in this case, the example was a bit contrived. I will be the first to admit. What I probably would have done if I actually had to do this in a real application is create certificates for each user rather than create just one certificate and use the combination of execute as and ownership chaining. I would have actually created 3 certificates and signed the store procedure with all 3. And that way, because the permissions are additive, the caller would have access to all 3 of those resources. But it is interesting to note that you can combine these different techniques, the certificates, the ownership chaining, and the impersonation, to create one solution that will work together if that is something you need to do. So let me jump back to the slides here. And it looks like we have a few questions. Someone asked of the reference to that TechNet webcast. The person is Lara, L-A-R-A, Rebelke, R-U-B-B-E-L-K-E. And if you just search the TechNet webcast for encryption and SQL Server 2005, I think you'll find that. And I should note she's also one of the co-authors on my book, having written the chapter there on encryption. So she's definitely an expert in that field. So the next question, we only create web applications and any direct access to the database is denied. What type of users should we create when migrating to SQL Server 2005? Well, that's definitely a great question. When creating web applications, it is the standard to deny direct access to the database by using stored procedures, basically depending on what your definition of direct access is. So someone has to have direct access at some point to that database. What you want to do is limit the ability of your application login to get data that it's not supposed to. The reason for that is, of course, that someone could get into your application server, get access to the database by virtue of being inside your application server and having access to everything it has access to, and then jump into your data if you don't protect it. And this is why we try to lock things down by creating stored procedures and views and these proxies. You can do this in SQL Server 2000 to some degree. Ownership chaining is actually a feature that works in SQL Server 2000. The problem in 2000 was if you had to use dynamic SQL, that ownership chain would break and everything would kind of go up in flames. You'd have to give that interactive login access to the base tables that the dynamic SQL was operating against. So what these new features let you do is bypass that and create stronger and better security schemes. So you really want to keep doing everything you were already doing in 2000 and then do more with these new features. So I hope that answers your question. And we have one other question here. And the question is, if there are a table and a stored procedure, and the stored procedure selects from the table, and they're owned by the same user, when another user tries to execute the stored procedure and the request fails, if the second user is granted select on the table, the procedure executes. Okay, so what you're describing is a broken ownership chain. But what happens when a stored procedure is called, and I think this is mentioned. Okay, so when you're calling a stored procedure in SQL Server 2005 and you don't have execute as on the stored procedure, what happens is that you, by default, execute as caller, which means that you get any of the permissions that the caller has, and that's what the stored procedure uses. Now, if you call a stored procedure that does have execute as and the ownership chain is broken, same thing happens. It'll actually revert and use the caller's permissions. So you want to kind of avoid doing that whenever possible. You don't want the caller, in most cases, to have access to anything. If you want to create a truly secure system, you want the caller to have a least privilege, which means only access to run those stored procedures or maybe select from those views. And then you want to use impersonation, ownership chaining, and certificate signing to selectively enable that caller to get more data when necessary. And one more. Will you experience any performance degradation with objects secured by certificates? And the answer is it should be minimal at most. I have not run extensive tests, but I actually have run some tests, and I haven't seen anything. I see no reason that you would see any. So I would say no. Go ahead and go crazy. So I'm going to move on now. And there's a couple more questions coming in. I'll get those in just a bit. So the basic methodology, and I've been discussing this all along, is what you want to shoot for is interactive users not having direct table permissions. Instead, you want to use proxies. You want to give the permissions to those proxies. And you want to make sure that you only give the interactive users permissions by virtue of the fact that they can access modules that participate in ownership chaining, impersonation, and certificate signing. So that way you keep your application safe, you keep your data safe. So moving along to our final topic, I'm just going to show you a little bit of basic administration and how you can look at the permissions as an administrator. So for database level permissions, what we look at is the sys.database permissions catalog view in 2005, and this has a few columns that you really want to pay attention to. The major ID is the object ID of whatever it is that you have permissions on. The grantee principal tells you who has access to that object. And the permission name is what has been applied. So is it select permission? Is it update permission? Is it execute permission? Finally, there's a state. Do we have a grant or do we have a deny? And of course, those are additive, so a deny will outweigh a grant if you have both. And then I'm going to show you how to look at which of your users are being used via which certificates to sign things in your database. So let's just jump over and take a quick look in SSMS that. What I've done is left all of this stuff from the previous demo. So we still have users A through D, and we have the tables created and the store procedures. So first what I'm going to do is use that database permissions view. And I want all the rows where the major ID is greater than 0. Major ID, again, is the user to which permissions have been granted. And if it's greater than 0, that means that they are a non-system user. So I'm going to go ahead and run this. So we use object name. I'm sorry, that's the object ID, not the user ID. And so we want the non-system objects. So we have the object names, and these are our stored procedures. We have user A has been granted execute on both of them. Now, it's important to note these are only explicit permissions which have been granted. You might remember that we also have users B through D, and you might be saying, where are their permissions? Because they own some tables, so they should be able to select from those tables and insert data and update and delete and do all those fun things. Well, those are not explicit permissions. Those permissions are only granted by virtue of the fact that those users are owners of the tables. So we call those effective permissions. Now to find those, it's a much more expensive query, so you actually have to do it on a user-by-user basis. The way we do it is we impersonate the user, and because I'm DBO, I can impersonate whoever I want. So I'm going to impersonate user B, and then I'm going to use the fn myPermissions function, and I want to know all of the permissions for table B, which is of type object. So the effective permissions for user B, for table B, are select, update, references, etc., etc., etc. We also have access to the column in table B. That's the sub-entity in this point. And so now I'm going to go ahead and revert back. But one other thing I want to show you, because this took me a little while to figure out how to do, this query shows all the certificate users, the sign modules that they're associated with. So in this case, we only have one. We've signed table B, get table B, and table C, and table D using the user D certificate, and that's associated with user D. And the important thing to note here is that we join between the crypt properties and certificates view using the thumbprint column, but to join to the database principals, so in other words, to find the users created from those certificates, we actually have to take a substring of the SID, which is created based on the certificate. So this gets a little complex. It took me quite a while to figure this one out, so I hope this helps you if you're doing something like this. So let me jump back into the slides here, and we will finish up, and then I'll get to the questions. So in summary, you want to handle your security in layers, and you want to make sure that your interactive users, which is the outermost layer, have the least possible access necessary to get what they need. And this is handled based on escalation of privilege. So you do this by creating shells, store procedures, views, and letting the users only access those shells, and those shells actually control access to the real resources which they sit in front of. So the ownership chaining, the impersonation, and the signing is how you do all that. And those can all work together, if you'd like, to create a really very flexible, very granular strategy. So as I mentioned before, you can get a free copy of my new book, Expert SQL Server 2005 Development. Here's what you need to do. Today at exactly 4:31 p.m. Eastern Standard Time, I am going to go to Amazon and get the sales rank for the book. You, if you would like a copy, do the same. Send me that number along with your mailing address, and the first 20 people that send me the right number, I'm going to take a random drawing of a few of those, and I will send you a copy of the book. So amechanic@datamanipulation.net if you're interested. Remember, 4:31 p.m. today. So if you have any questions, I will pass it back and start answering those.
Excellent. Thanks, Adam. I do want to remind everybody that for more information, you can print a PDF of today's session. To do that, just go to the File menu in your upper navigation bar. Now we're going to get to the remaining questions and answers here in just a moment. Please feel free to submit them into the Q&A panel found at the bottom of your live meeting screen. Now I'm going to be posting a survey here in just a minute. If you could all please take a moment to fill it out before you log off. We do appreciate your feedback. As a reminder for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcasts. You can go here to access this webcast, which will be available for download in about 24 hours. Now, if you have any webcast content ideas, if there's something out there that you would like to see and haven't yet, I'd love to hear from you. Just take note of this link here. And for anybody who's interested in receiving a free 14-day trial of Microsoft Office Live Meetings, you'll want to visit Microsoft.com/presentlive. Now for filling out that survey today, you're going to be automatically entered in to win this 30 gigabyte Zune digital media player. That gives you a little incentive to fill that out for us today. And here is the survey. Please follow the links provided to complete today's webcast evaluation. And Adam, do you have any questions waiting in the queue for you?
I just have one left. The question is, I thought chaining was not recommended. What I think you're thinking of is cross-database ownership chaining, which when you upgraded to SQL Server 2000 Service Pack 3, you probably saw a little option, would you like to enable cross-database ownership chaining? Not recommended. The reason is the cross-database ownership chaining can create some very, very strange and interesting login problems and security problems, which are a little bit beyond the scope of this talk. But basically, you do want to avoid that, and you can avoid that pretty easily. Even if you do need access to a resource in another database, you can actually go ahead and use the proxy logins like I showed you, sign your modules using the certificates associated with those proxy logins, and then your logins, your users that are calling the stored procedures will be able to get access to whatever those logins have access to, even if it's in a different database. So we can even do away with the cross-database ownership chaining problem using all of these techniques. There was a question about the times. It's 4:31 Eastern Time. I might have gotten the Eastern Standard versus Eastern Daylight Time incorrect. What we want is 4:31 on the U.S. East Coast, which someone's just mentioned is Eastern Daylight Time currently, so I apologize if I got that wrong. Also had a couple questions regarding the name of the book. It is Expert SQL Server 2005 Development, and that's being published by A-Press. Final question I see, can we download the code for the demo? Yes, I will go ahead and post the code on my blog, and my blog at sqlblog.com with a lot of different people. So I hope that you'll all come and check out our blogs. There's some really good bloggers on there. I unfortunately barely ever blog, but some of the other guys do an awesome job. So please come check out our blogs, and I will post the code a little bit later today. And I will also mention the winners if they would like to be mentioned. So thank you very much again for attending the webcast. I appreciate it.
Great. And with that, I do want to extend a very special thank you to Adam for your presentation today and taking the time to answer all the questions we had come through the queue. I also want to thank the audience for attending today's Msdn webcast. Ladies and gentlemen, this will conclude today's session. The audience may now disconnect from the audio portion of today's presentation.